Great. Well, hello, everybody. And I'm Jim Gatto, as Zach said, and we look forward to talking a little bit about kind of where things are from a technology perspective. Two very enthusiastic talks so far. Zach was great as always, and the last speech was very hard to kind of follow the energy, but we're going to try to make that happen here with this great group. I kind of feel like we have the band back together. It's a pretty similar panel that we did last year, and hopefully we can entertain a little bit. So let me introduce first, just very briefly, I'm going to say a word or two about each of the speakers, but then let each of them kind of talk a little bit about their background. We start with Nick Thomas, who's the Senior Director and Head of Gaming at Immersion. One of the fun facts about Nick that many people don't know is he's about 1,000 game credits to his title. So maybe you can talk a little bit about your kind of professional experience, and we'll kind of say what the company does and products for a second, but just talk a little about your background and how you got to where you are today.
Sure. All right. Well, thanks, Jim. So as Jim mentioned, I've been in this space for a long time. I work in the creative domain. So being with Immersion is fantastic because it's sort of the synergy between technology and creativity. But my background has been in the creative production realm. I founded and ran a company called Somatone for a decade that served as a creative service provider, primarily in the casual game space. So 1,000 games sounds like a lot. It's actually doable when you're looking at casual focused games. So historically that was PC downloadable, and then into the social game kind of revolution, and then into mobile. In that space, there are thousands of games that are produced annually. So, having 1,000 titles sounds like a lot. It's a good chunk of work, but has to be kind of kept in perspective.
Great, thanks. And David, so I don't know if any of you looked at the website at Leap Motion, but I really love the fact that David is described as the mad scientist. Kind of a cool title to have. I think he earned it. One of the fun facts about David is in 8th grade, he read Steve Hawking's Brief History of Time and found a simple way to test the general theory of relativity. That's pretty amazing at that age. David, can you give a little bit about your background and kind of where you're at today?
Hello. Let's see, a little bit about my background. My background's in math and physics, and I was working on like 14 different research teams around the world, whether it was like fluid mechanics or laser radars or atmospheric science or Mars missions. I was at all sorts of crazy things, but I really just wanted to work on one thing, and I wanted to make sure if I was going to focus on one thing, it was a really fundamental problem in the world. And I felt like technology is this massive driver of change, and that seemed to be the place to push. But then, what is the limiter in technology? And I felt like, philosophically, people should be better with technology than without it. But when that wasn't the case, and you kind of look why, it usually has something to do with interfaces. It's usually not that the computer's too slow or the person's too slow. It's usually something between the person and the technology around them that's preventing a fundamental exchange from occurring. So I decided to focus on interfaces, and I founded a company called Leap Motion, and we basically track hands. So the idea is that if you want to interact with computers in a sort of physically plausible way, if you want to make sort of virtual reality like actual reality, you have to use your hands. They're sort of the original human universal interface, and that's what we focus on, and we're trying to change how people interact with technology.
Great. And we have Richard Marks, who's senior researcher at Sony Computer Entertainment, literally a rocket scientist, studied aerospace engineering. And now working a lot with video inputs for games. A little bit about your background, Richard?
I've been at PlayStation for 15 years now, and my focus has been mostly on interactivity and using technology to figure out new ways to do, like what David was saying, similar. I guess the reason I focused on it so much is that I've been a big fan of video games for a long time, and I feel what separates them from other media like film or books is the interaction that you do. It's not a passive experience, it's an active experience. And being able to do that in new ways and change the kind of capabilities games have to work with has been my goal at PlayStation.
Thank you. And finally, we have Tan Lee, who's with the CEO of Emotiv. Tan has an impressive collection of awards. I'm going to go through just a couple of them real quick. In 1998, she was named the Young Australian of the Year. Since then, more recently, she was named in 2010 by Fast Company as one of the most influential women in technology. In 2011, she received a distinguished award from the AutoVision Innovations Group. 2012, she got the Advanced Global Australian Award for IGT. 2013, Tan was named National Geographic Engineering Explorer. And in 2014, she got the Good Day, hopefully I said that okay, USA Global Innovations Award. We can't wait to see what happens in 2015 with you. But please, a little bit about your background, please.
So I grew up in Australia, and one of the reasons why I started Emotiv was, I must have missed the memo somehow that technology was changing our world radically. And I started my career as a lawyer, but we started a few years into my legal practice, I realized that we were starting to form a new group to service technology entrepreneurs, and I realized that technology, and I started reading a lot about technology, and I found that much like some of these guys here, it's changing the way that we live every single day, and I wanted to work on something and be part of the innovation, be part of something that was going to drive the change. And the models that I really fell in love with was the internet and the web, that really democratized the capacity for driving great revolutions because it allowed innovation to happen around the periphery. It was engineered that way. And I had an intrinsic interest in the brain, but when I wanted to study the brain as an outsider, I found that it was extremely difficult to do that because of the inherent systems were so expensive. It was cost prohibitive, it was cumbersome, and it was locked up in many ways to people who had a lot of experience or had the access to funds. And so I wanted to create technologies that would be spatially relevant, that was high resolution, but was portable, allowing us to study brains in context. And I've been doing that for a decade now. We have 2 products that really focus around allowing consumers and researchers to gain access to brain data.
Great, thank you. And just briefly, it's kind of a hard panel to follow as far as credentials. I'm Jim Gatto. I'm a lawyer with Pillsbury. I have an engineering degree and physics minor and kind of went into law instead, but really do love working with all these innovative technologies and business models. And so if you're asking why a lawyer is on the panel, it's really more from the technology perspective. But okay, look forward to getting into an interesting conversation now about the kind of where things are, where we're going, and in general, and then with some of your own technologies. So let's focus first, putting aside your own companies and your own technology. Just as a quick update from last year, what do you think has been the biggest innovation over the last year that's kind of impacted the neurogaming space? Well, let's go. We'll maybe start with Tan and come down this way.
I think, just following on from what Adam's talked about, I think Adam's absolutely right. I think for the first time, we have the capacity to really look at closed-loop systems that dynamically allow us to change and engineer an experience for the user and the participant in ways that we haven't been able to. We've seen huge advancements in AR, VR, in capture technologies around input devices that capture EEG data, and we're seeing, a multidisciplinary approach that we haven't seen in the past, bringing together people like us here at this conference to start to look at this in a cross-disciplinary way. I think in the past we've seen a lot of silos, but I'm seeing in the last year a lot more integration. So it's very exciting. I think the fact that VR is now emerging gives rise to a greater need to look at new ways of immersion and new ways of interacting with the content. I think that opens up new possibilities for different types of input devices like leap motion, like the EEG stuff that we're working on. So I think that's really exciting.
Richard?
Yeah, I would have to say, I think the advancements in VR have been dramatic in the last year. If you've tried any of the most recent VR headsets, the quality level has reached this point when I think people no longer have to focus on how good they are. They deliver enough quality to let you have an experience or get this feeling of presence, which is this very vague word, but basically means you believe what you're seeing is real around you at a kind of below your conscious level. And we have an experience that some people tried yesterday, and there's a virtual desk, and one person, and that happens often, leaned on the virtual desk in order to move, and then there was no desk, so they kind of had a step. So once you start to believe, there's different things. There's presence, and then there's immersion, which are a little bit different. But once you start to believe that experience is really happening, I think that changes the experience quite a bit. And the thing that's exciting for that for games is that you can then change what's happening around you, not just view it.
David?
Yeah, the ability to actually have these wearable displays in general really does change the equation. That you can actually, put stuff on people's faces, and that's sort of considered to be like totally cool now. Whereas like in the past, if you wanted to have an eye tracking desk, with motion control and everything, you have like it's a really complicated endeavor. And being able to put just sensors on people's faces as like a normal thing. Now you can look people's eyes, you can look at their mouths, you can look at their hands, like out from their face, you can do the EEG, you can basically do everything, and you can really, as Tan said, build those closed loop systems, and that's a really big deal.
I think I would answer that pretty broadly and just say, a year ago, many of us were sitting on the same stage, and these, kind of futuristic technologies, these progressive technologies felt pretty far out. I mean, even a year ago, VR felt like kind of a distant technology and platform. And 1 year has elapsed, and just as Richard's saying, it's basically arrived. So we're seeing the synergy of all this technology come together. We're seeing it now go mainstream. We're seeing adoption in the consumer market, which is super exciting for Immersion in particular. We see haptics really becoming widely adopted as part of the way people experience their technology. And it's no longer concept, it's no longer kind of design research, it's now actual product, which exists, is tangible, it's real, you can go get it today. And I think that's super exciting.
So it sounds like we feel like we're at the kind of the inflection point on the hockey stick here.
I think we're starting.
Great. So let's talk about each of your individual companies for a little bit. So what's been the biggest kind of change in the last year at Immersion?
I think what I'm saying, we're seeing 20 years of research. For those of you who don't know Immersion, I'll just give you the quick highlights. We're a 20-year NASDAQ-traded tech company, and we're solely dedicated to innovating haptic solutions, designing, creating, innovating, and then deploying these solutions, both to hardware, technology partners, and then to content partners as well. And we've been kind of, I don't know, some people know who we are, but I'd say from the mainstream consumer level and even in the gaming ecosystem, kind of under the radar. And that's really changing now. We're seeing much wider adoption of our technology, not just on the hardware side, but now with game developers and consumers actually expressing their own interest and desire to have haptics as part of the experience of their mobile entertainment.
Can you speak a little bit to some examples of how you're using haptics with gaming, and particularly on I know you're doing a lot with mobile, and how mobile is kind of a subset of that?
Well, mobile is, I'd say, our primary focus right now. So most people know Immersion's technology in the gaming space through Rumble and DualShock. That's the technology we invented and licensed to Sony and Microsoft, and that's been around for a decade now. So we have a long history in gaming. We've taken a lot of that knowledge and all of the learning that we've done there and applied that to a much more nuanced, much more sophisticated set of tools and technologies for the mobile experience. So I would say, instead of the Rumble sort of, chainsaw type of approach to haptics, we're down to a scalpel. And we're able to do nuanced, high fidelity, almost HD kind of quality haptic effects and integrate them into gameplay in a dynamic way. So it's not just a matter of rumble on, rumble off. We're able to create envelope, texture, contour, shape, amplitude, duration. I mean, really the whole three-dimensional design approach is now available to us, and the creative applications to that in a gaming design sense are virtually limitless.
So I think we talked last year a little about kind of almost like a haptic language, where some of the input is not just the rumble, as you say, but that rather through the patterns you can kind of convey different messages or have different feelings. Can you talk just a little bit about that and kind of where you are with that?
Yeah, so we did a UX study where we had just novice haptic, just basically just people off the street come in. We gave them a very basic haptic control interface, and we asked them to try to communicate one of 8 different emotions. So, happy, sad, silly, curious, frustrated, what have you. 8 different emotional feelings. And then we brought in a separate control group and asked them to guess which of these 8 emotions they were feeling. So what you would expect in just sort of a random guess scenario is roughly 12% accuracy, right? You have a 1 in 8 chance of guessing correctly which emotion you're feeling. What we found is that the range of accuracy across all 8 was between 60 and 70%. So that was a really interesting study for us in proving that not only could we communicate or use haptics as a design sort of experience, but we could actually communicate emotion. We could translate haptics into a sense of fear or anticipation or happiness or success or what have you. So that's sort of a lab type of investigation. The application of that in games is broad. You can do narrative implications with heartbeat or with timer running out, or you can do flourishes for leveling up or completing. You can have a much more dynamic integration with engines or physics-based events. So there's a really wide range of applications with that language that we're discovering.
Great. Well, one more question. So if we look forward over the next year, what do you think is going to be the biggest kind of news or development that'll come out of Immersion?
I would say more. We're already seeing a lot of exciting news just in this year, especially compared to where we were a year ago in terms of adoption. So, what we're looking for is ubiquity in the mobile experience, and we want to see everyone approaching haptics with the same sort of basic approach as they would audio. It's not an outlying technology anymore. It's sort of a core basic component of game design, and game designers and producers and developers and publishers are all implementing haptics as a core part of their standard offering.
Great. Thank you. David, as far as gestural control and leap motion, what's kind of been the most significant changes over the last year for you?
I would say the biggest change is that probably around last year, people were primarily focused on using gesture control with 2D screens. And now people are primarily focused on using gesture control with 3D screens, or 3D, and particularly the wearable displays. And the differences between those is actually, it's not just 2D and 3D. It's sort of when you use your hand and then there's a hand on a 2D screen, there's a hand here and a hand there, and you're kind of trying to take possession of this hand that's out there, which is totally possible and cool. But then when you pull everything into a wearable 3D display, your virtual hand is your physical hand. And it's all, and the virtual space is the physical space, and it's all just one space. There's no longer any sort of remote interaction, and so that really brings things from from an indirect form of interaction in a way an indirect form of interaction to an actually direct, physically indistinguishable form of interaction. And then with wearable sensors, you can because it's worn, anywhere you look, anywhere you can see your hands, you can track your hands. Whereas in the past, the sensors would be out in the environment, so if you turn away, it wouldn't necessarily track them. But now, because the idea of just saying anything that you see, it sees, it massively, simplifies a lot of things. And I would just say, overall, the last year has been lots of the simplifications of problems that were sort of artificial to the sort of two-dimensional computing environments, and now you can really focus on, okay, how do we actually do physical interaction with virtual objects?
Great. And what are some of the examples of the way in which you guys use gestural control with games?
There's almost there's almost too many to say. There's everything from there's when you're an astronaut and you're floating around in space, and there's lots of objects sort of flying past you, and you're trying to move them out of the way, and there's simple things where some guy's just holding like a fire, what do you call it, a lamp, as he's going through a cave, and there's really sort of anything that where you use your hand, where you would imagine your character using your hands, all of a sudden actually using your hands in the virtual space.
Great. And same question I asked Nick. What do you see as far as looking forward a year? What do you see some of the biggest changes coming down the road in your area?
I think the next year we're going to start seeing what's happening for virtual reality happening for augmented reality. So that means that people will start thinking more about transparent displays, not just about opaque displays. And that, I think the change there is in many ways bigger than the virtual reality one, because we're no longer talking about removing ourselves from the world. We're talking about really finally unifying the sort of digital and physical realms.
Right. Richard, what's happened last year at Sony in the eye tracking and areas you're in?
So we've been, my group is a research group, so we're always looking forward into what new interfaces could be. I've actually done some analysis, and I find it really interesting on the interfaces, how they kind of map from very abstract, like a keyboard is very abstracted, all the way to very literal, maybe like a treadmill is a very literal interface. And in between, there's a lot of different capabilities. Eye tracking is a spatial kind of thing, but it also is a little bit abstract because you don't know what you want it to do necessarily. And then what I've done the most work with is spatial interfaces, like something like the PlayStation Move, or like the STEM system, which is out here, where it's a little bit abstract because it's not your hand like David works, but it knows where your hand is. And so you have the abstraction of a controller mixed with the literalness of the position of your hand in it. So I think that's a very powerful combination too, and has different trade-offs. You don't see your real hand in VR, for example, but you do. And we did that work before in 2D, like similar to David, but it's very hard to see it on a flat 2D screen and have a 3D interface that makes sense to somebody. And it's become much easier to do with virtual reality.
So what do you see as some of the more interesting applications in the near term for that?
Well, I think what's a little bit different for us is, we're PlayStation, and our system works with PlayStation 4. So there's a large, very interested audience, and we have a known controller and the known platform, so content creators can make things, and they can really target an experience to their players and know exactly how it will be when they get to try it. And that's different. The other people working on VR have very different goals to be maybe more customizable and things, but we have a very locked down system. So I think that's different. We're pretty different in this space for that reason.
Right. And what do you see as the kind of the biggest changes looking down the next year?
Well, the biggest thing for us is we'll release our virtual reality system the first half of the year. So seeing a large, installed base start to happen for virtual reality, I think will be interesting for the world to watch and see what that means. There might be other people doing that same thing at the same time, but I think next year is going to be see the numbers of people who own headsets go up, and then what does that mean to the industry? And then what experiences are the ones that people find that works that way, and which ones, stay in a traditional kind of gaming space? I think that's going to be very interesting to watch.
Great. And Don, bring us up to date on last year at Emotiv.
So last year, I would say on the external side of things, I think most people are seeing that we've been working on a second generation product, the Insight that's coming out this summer. But internally, we've actually been working on a lot of software updates. I think, for us as a business, whilst the hardware is a very core part of the ecosystem that we need to support, because there isn't anything off the shelf that you can buy that really does what our systems do right now. Ultimately, where the biggest opportunity lies, I think, in the brain space is in being able to understand what's going on, what's happening. And so we've been investing very heavily in trying to gear up for the big adoption curve of people that are using our systems and coming online and coming onto our cloud service, and what that is going to enable in terms of understanding, normative databases, understanding how the brain changes over time, looking at a much larger scale of data and information on the brain. And so we've been doing a lot of work on the software side, and that's what's going to be, I guess that's what we'll see come through in the next 12 months.
So what have some of those developments led to as far as the type of software or functionality that you've enabled with that?
In terms of, so there will be two aspects. One is a kind of like a brain activity tracker, much like a Fitbit, but for your brain, looking at being able to allow you to track very generally the types of things that you're doing. And in the background, we're looking at connectivity, looking at, attention, looking at focus, looking at stress management, and giving you information back to help you make better decisions every day. And on the front end, it looks very simple, but on the back end, what we're doing is we're starting to calibrate and starting to piece together how some of the slow-moving shifts in your brain over time, and then slowly being able to feed back better information based on what you're doing, and also based on aggregated users. I think that's a very it's still very early in terms of being able to launch that for the consumer base, because Insight's not quite out yet, but that's what we've got in the pipeline. On the research side, what's really interesting is it creates an environment that will allow researchers to accelerate whatever it is that you're doing research on. So let's say, for example, you're interested in looking at depression. It's much easier to have not just a patient population, but also to have a normative population that you can compare across. So that allows us to do research in a much more different way compared to how we're doing science research now, which is, we study brains when there's something wrong with them. We look at patient populations. That's a much smaller sample. Everything has to be statistically relevant, not really looking at the big data and how it applies to the brain. But, Emotiv is really looking at it in a very different opportunity.
And with respect to the software you're doing, a lot of it's research at this point, but are you kind of developing it for particular kind of near-term applications, or more just kind of a broader platform?
So the software is really an enablement tool for research, both for our own research purposes. So, a lot of our community wants to have greater fidelity in terms of, let's say, mental commands, being able to control objects with your mind, right? Right now, we can do 4 distinct actions, so being able to say left, right, forward, and stop, versus a neutral state where you're not trying to do anything. That's kind of interesting, but we haven't been able to move the needle a lot further from that based on our classical models of research, because we're relying on bringing people in, collecting data, and then building, machine learning algorithms based on a smaller sample set. But if we're able to mobilize the existing Emotiv community to kind of give us, think push, think pull, think disappear, think fire, think ice. We have tens of thousands of samples of people over multiple segments. Then we're going to be able to build a much better model for classification. And that's the kind of thing that we'll be able to enable not just for ourselves, but for the research community. So if you're interested in a particular question, you can actually put that question out and get a response back and actually compute that information.
So you're kind of leveraging an open source model around that?
Yeah, so it's all about distributed and accelerated platform for research. So we've been doing a lot of the tools to enable that, because we have a very large installed base of users with a nice array, with 16 channels of EEG data, all in the same data platform. Insight has 5 with a nice spatial array, so you'll be able to use either platform.
Great. So not to be a downer, but so we've talked a lot of enthusiastic stuff, all the opportunities, all the good stuff. There's always challenges to kind of continued commercialization. And David Richard talked a little about the 2D, 3D challenge. And beyond that, maybe we just kind of go down and just real kind of quickly kind of talk about what do you see as some of the biggest challenges or obstacles in your areas to kind of take it to the next level, if you will?
Well, I'd say on our side, it's really the business proof points where we see friction. Everyone who experiences a haptic demo thinks it's cool, right? Haptics are cool. That's pretty easy in terms of bringing the haptic technology into the sort of mainstream commercial game publishing development ecosystem. Where things break down is, what's the ROI on an investment in new technology? How do we offset an investment in engineering to deprioritize other features and add haptics in as part of the core offering? The businesses or the companies in this industry are, they're very smart. They make very, very hard-headed, practical decisions when it comes to how they're going to run their pipelines. And that historically has been the primary challenge for us. I will say, though, that we're actually now moving, I think, to a much more successful place of outreach, because we have, for the first time, dedicated A/B studies that we have done in market with developer partners to measure the impact of haptics on the game experience. So we're looking at, just standard control A/B test sample groups. We're looking at retention, engagement, even monetization, play length sessions, and so forth. And what we're finding is that across the board, we're seeing dramatic improvements in the consumer response to haptics versus the non-haptic control group. So that basic kind of analytical data, which is really the kind of bread and butter of how the mobile gaming industry works, is proving positive for haptics. And to us, while historically it's been a friction point, and it does continue to be, we're getting more and more data that supports our value proposition, and that's very encouraging for us.
But my guess is the result of the A/B testing is not surprising to you, but if there was one kind of insight that came out of it that is surprising, what's been the most kind of revealing thing to you as a result of that testing?
Well, yeah, I mean, we're drinking our own Kool-Aid at Immersion, and we're all fans of our own tech, but I think what we learned in our latest study, which was surprising, was that the primary demographic that we tested was really the casual audience. So this was middle-aged women, right, between, 35 and 50 or something to that extent. We have always believed that, the traditional core gamer who has a mobile game experience will get the haptic experience because of their, familiarity with Rumble. That's a pretty linear translation of that experience. But the core demographic we most recently tested are an audience that's not so familiar with Rumble, and for many of whom haptics are a brand new experience altogether. They've never really had a haptic interaction that's meaningful prior to this dedicated A/B test. And I'd say that was the most surprising result, was that this new demographic, which I think we had suspected might be less friendly to this new experience, actually was very enthusiastic and found it, very exciting and interesting, and brought meaningful lift across, retention and engagement, and even significant in-app purchasing improvements, which, for us as a proof point, I mean, that's basically the best stuff we could get.
Great. David, what's been the biggest challenge, or what do you see as the biggest challenge?
I think in gaming right now, the biggest challenge is sort of for hands is transitioning from a controller mindset to a hand mindset. You can call hands a controller, but at the end of the day, your hands are not game controllers; they're hands. And there's actually a really interesting distinction there, in that you're no longer sort of you're no longer kind of using joysticks to control things in a very directional way. Everything is very, very direct. And so there is just a little bit of sort of understanding, okay, there are certain things that immediately are not necessarily things that you want to do. So you don't necessarily want to make a game that's entirely around using your thumbs as joysticks, pointing in the air or something. But there are a lot of things you can do that are really compelling, like you're doing some kind of sorcery or something, and all of a sudden you could never really do that game otherwise. So kind of understanding the spectrum of things that are possible to be made, and understanding and sort of getting into a mindset of sort of hands first, physicality first, rather than, I think, what a lot of gaming has been in the past has been in some way, in many ways, indirect. You're controlling some other character that's in third person. You're having him walk through a world while you're sitting still moving your thumb. It's a and as with the wearable displays, everything is increasingly sort of mapped one-to-one, and kind of making that mental transition and helping people do that is probably the biggest thing.
Great. Richard?
Well, as a technologist, all these sensor and display techs are really exciting to me. And I think the challenge we have as a company is trying to balance what we put into products. And it's always kind of a trade-off between cost and encumbrance versus the experience they enable. So trying to find the right combination of things and find a set that makes sense. And it's hard because everyone's like, oh, you should add this to the headset, or you should add this in. And of course, those things are all interesting to add, and we like that. But then the cost goes up, and then there's less people that might wear it because it's bigger and heavier. And so it's a really hard balance, I think, for companies to find which one of these new sensor capabilities makes sense for the products they want to do. And I think the only answer to that is always to go back to the experiences you want to give to your customers. And if those experiences need the sensors, then they should be put in there. And if the experiences you want to make don't need them, you shouldn't probably be adding the cost and weight and things like that. So that's our biggest challenge.
Imagine, given the magnitude of the challenges you guys the opportunities you're pursuing, there's lots of challenges, but what are some of the more short-term ones?
I think our biggest challenge is really finding the right content piece that will compel people to want to buy a headset. Right? I think one of the biggest challenges for most of EEG-based companies is that it's a very visible product. You have to wear some gizmo on your head. And so it is something that, if you are reliant on people wearing it every day, all day, it's going to be a very tall order. I don't think we're anywhere near that adoption point yet. So what we have to rely on is being able to have something that's compelling enough for people to use in short bursts that still provide them with important and valuable insight and feedback that will make them want to use it again. And so the variety and the range, and so for us, the content piece is really, really important. And I don't think we're there yet. I don't think we have a content answer that says, this is our killer app, so to speak, right? So I think we're still searching for the right killer app. We're building a platform in the meantime to enable as many people to explore with the technology as we can, knowing that we haven't found the killer app yet. And so we're not at the hockey stick inflection point yet. We're still trying to search for what is the right space for that. I don't think it's helping people to necessarily relax, because buying $300 for a headset that just helps them to relax is a very tall order past the early adopters. If you can help them play a game, does that kind of move the needle? Maybe. Does it, if it helps with a child who has ADD or ADHD, does that move the needle further? Yes, but it's going to take a collection of things until we find the right killer app. And so that's why we've been really focused on the software piece, the enablement piece, the technology platform that allows all of this to be more democratized, to be more openly available, so that more people can start to participate in the conversation.
Right, and to pick up on your point about collection and what Richard said about all these different features you can put into a headset, and it's a trade-off. Along those lines, these are all each interesting technologies and can enhance games. Where are things with respect to kind of the integration of using these things together and platforms for kind of facilitating bringing together these disparate technologies into a single game or app? Maybe you want to start, Tom?
I think it's going to take a lot. I think that it's ultimately a question of cost, integration, and then content, right? It's a multi-dimensional piece. It's not something that we can say, oh, it's a cool thing to add. Yes, but to do what that you can't do today? And is it sufficiently of value, of a value add that justifies the cost and the integration? I think we're going to get there eventually. We're not quite there yet in terms of being able. I think that with VR, we're getting closer to an environment where it does make it more compelling to explore alternative forms of interaction. But as the EEG maker, we need to do a lot more on our algorithms to get the latency down, to get the accuracy down, to get the robustness of the inputs down. So that you have greater range in terms of what you can do.
Richard?
I think a lot of these technologies are really synergistic, and so sometimes it is the case that when you have one and then the other one becomes more important because they go together so well. I think haptics and spatial controllers are really like that. If I can move it and then in virtual reality or in a game, when I get to a certain point, I feel it click or touch, or I feel the weight change or something like that, that's a really powerful thing versus it just happening kind of arbitrarily at a time. Like Rumble is more like that, where it usually is just not as dependent on what I'm doing with my body. It's more maybe what's happening in the virtual game or something. But the new haptics things are, you can do a lot more with spatial input. And similarly with hands, if you have a controller and you're flying a spaceship around, but you can lift your hand off the controller and do something with your hand, that's a really suddenly powerful thing to have it. Don't necessarily replace everything you already have, but you can augment it, and then you get a lot more capabilities that you can design around.
Yeah. Great. David?
Definitely, hybrids are super cool. Like hand tracking and eye tracking are really cool too, because if you have hands, sometimes you have to kind of be coordinated, and some people use technology not coordinated. But so, like for example, somebody could be trying to push a button and they could hard up miss the button. Like here's the button, like completely. But if you have eye tracking, you see them staring at the button, you see them trying to move their hand towards the button. You can kind of use the eyes for focus and the hands for intent, rather than you're relying on their physical coordination. So there's lots of that's another interesting type of hybrid.
The flip side is with just eye tracking,
yeah.
You just have to maybe hover and look at it for a long time, which
Stare
is not,
really intently.
That's not nearly as satisfying as having both, right?
Yeah, exactly. With hands, it's not as much. I do think that the hands kind of go well with a lot of technologies, and so it's not going to be cost. it's going to be, and it's not going to be size because the size is very small. There's just a certain maturity and like sort of a functionality, reliability, and maturity where basically it crosses some threshold where anything that doesn't have that technology is now considered sort of insufficient. Like, you know, all headsets will feel like I have my arms cut off unless I have my arms in it at some point. And so I think we're very close to that threshold, but it's definitely be before this next conference, but it might not be like, today.
Got it. Nick?
So I mean, I agree with Tan. I think it's kind of a cost-benefit question, and there's also a chicken and egg in terms of what content would even support these new products. I mean, on this stage, we've got like a super product, right? We could have an HMD with EKG sensors, with gesture control and haptics, right? That would be amazing if we all and eye tracking, right? We put that all together and you could do anything you wanted.
But
what would the game be,
right?
right? So we don't have that game, and so there's sort of like this, we got to move both sides of the ledger forward as we innovate, and then the content catches up or pushes us to innovate further, and those things I think will draw us all closer and closer together, where hopefully, next year or 3 years from now, we have this kind of culmination of all of these individual siloed technologies all connected and working together towards a more common goal of just like true full immersion or whatever that thing is that we're working towards.
Yep. Sounds like the middleware to kind of tie it all together would be a great.
Right, and then Unity comes along and just enables the whole package, and then we're off to the races.
Great. Well, I have a few more questions, but let's see if audience has any questions they want to ask before we have a few minutes left. Question?
Wait for the mic, please.
Hi. Ooh, there we go. Hi, I'm Beth Bergozinski with Pear Therapeutics. Great panel, everybody. Thanks very much. My question is about the downward cost of hardware, right? We're seeing this across the board. And Tan, you mentioned $300, and people are not going to buy a $300 headset until there is a killer app. But where's your industry going to kind of pull this down to more reasonable levels?
Well, in the EEG space, when I first started working in this space, you can't even touch an EEG system unless you had $60,000 to get a biosemi, and that's not an FDA-approved system. It's not a neuroscan system. This is a system for research. You then have to get the software. By the time you add everything up, and then it's also setup time, which is very expensive. You need a dedicated technician. We've moved the needle quite significantly by slashing the cost 100-fold, right, down to a level where it's somewhat consumer price point. The issue, I think, is not around the $300 price point. I think the issue is more around getting enough content around it to justify it, at least in the early stages. Being able to get to a point, I think it's really a matter, certainly I think at some point in the future, we will be able to get it down to like that wonderful $99 price point where NeuroSky has it, but that's a one-channel system. It's a very different set of sensors. It's difficult to get a system that has active amplifiers at each source, that has new technology in terms of polymer sensors that are hydrophilic. Those material costs are expensive. We don't have the installed base yet to drive those costs down. So I think it will take time. I mean, some of the other panelists, I think, like with Immersion, you've had 20 years of technology, so you're going to be able to see much better, sort of acceleration in terms of cost reduction.
Sounds like Tom wants you guys to lead the way on the cost curve down.
Well, I mean, I think that's one space where Immersion has a huge advantage, is that this is, we don't make hardware. We make software that drives hardware, and we license hardware solutions. And so, that's already been solved for us. You guys, anyone in this room could go home today at lunch, download our SDK, and by dinner you'd have haptics in your game. It's done. The hardware's in the phone. So it's just the creative applications of that technology, which is the work that we have to do. So it's not a pricing issue, it's an education issue, it's an informational issue, which is a different set of challenges, in some ways also full of friction. But haptics are accessible today, and that's something that for us is just a great advantage.
David, where's the kind of the cost curve on your stuff?
It's pretty small. I mean, we kind of piggyback on top of the consumerization of cameras in general. So we use, and LEDs. So like all phones have cameras and LEDs. So we kind of use just slightly different tweaks of those. So everything is very, very inexpensive, like dollars. But it's not to the point where it's already in all of the devices like the haptics are. So it's really just. I guess that one switch is yet to occur, but it's not as much of a price. Not as much of a price thing, I would say.
Yours is not so much independently priced, right, as far as if you bake it into the platform, but any thoughts on the cost issue?
Well, I mean, that's one thing my company does basically is commoditize new technology and make it so the cost does get driven down because we measure things in millions, not thousands. So by putting it into a more mass market product, it does help make it available for other uses at a lower cost.
Sure, great. Any other questions? Yes. Right, yeah.
Hello?
Yeah.
Oh. What modalities are receiving? Hi, I have a question back here. Somebody else have the mic too?
Okay, why don't you ask yours while we're fixing the mic here?
Okay, thanks. Hi, my name's Brandon Stagel. I'm here from IMRO, International Mental Health Research Organization. This question's for Tan Lee. With your Emotiv headset, you talk about the idea that it's a conspicuous device and people wouldn't probably not want to wear it full time, while they're going about their day. But you also talk about the crowdsourcing potential for research of understanding how the brain works and in different situations, different behaviors, and this seems like it'd be a really useful tool for helping. People with monitor the health of people with mental health conditions, especially when it gets in a dangerous space for them. Do you foresee, perhaps in the near future, the ability to have headsets that are inconspicuous enough for people to wear them full time to kind of multiply the amount of time and the amount of data you can get from the headset to help people and patients in particular?
Absolutely. I think that's the key, right? So I think for most hardware companies, we see it as 3 product cycles before we get to something that's much more of a mass market product. I think we've done a good job with our 2nd gen product. We're on our 2nd cycle at this point, and the insight is considerably better. Like the Epoch uses a saline-based sensor solution, whereas Insight, there's no prep at all. It's a hydrophilic polymer sensor. We still need to do one more version before I think we get to something that's a lot more ubiquitous. I think we definitely have our sights there. It's just a matter of working on that and doing the necessary R&D so that we get to that point. But I completely agree with you. I think there are some realistic telemedicine type applications that are viable right now, even with Epoch and Insight, given the nature of the setup time. But I just don't think it's enough. We haven't done enough yet. We're not at the point where it's capable of being used by everybody. I just don't see it yet, not with the level of content we've got. And I also think that there's also a barrier to adoption based on just the form factor that we've got right now. So I think as the founder and as someone who's been pioneering in this space for a decade already, I definitely feel like this need to kind of keep pushing harder and asking more questions around what else can we do to improve the form factor and still not compromise on the quality of the data that we can get back, because ultimately that's where the value is. It's not in the whimsical fun stuff, but it's in this 2 billion people, this $2 trillion economic burden every year in terms of neurological impairments. How are we going to make an impact and dent in that unless we have a better model for understanding the brain? So I think we've got a long way to go, but I think we're kind of pushing in the right direction right now.
Thank you.
Great, thanks. Gatto.
Commercially, you've made your individual modalities viable. Are you aware of any aspects of interface that are anemic, that are not receiving attention, that are on the radar in terms of possibilities, but are not yet to the extent that you and your companies consider them to be viable in the near term, that would benefit from someone stepping in and looking at those gaps?
I mean, I think Immersion's philosophy is that haptics have value, almost universally. There's a creative and interesting way to apply haptic feedback to anything you interact with your hands, and it's not even restricted to your hands. It's the sense of touch. It could be on an HMD. It could be in your toes. It doesn't really matter. I mean, we haven't looked at sneakers. There's plenty of things we could do that are unaware of in terms of what's possible. Part of my work is to actually find people who are innovating and think about creative ways that we could solve new problems we didn't even know existed. And that sort of just opens up the universe of use application. I'd say we're a little focused right now, but we're certainly broadly looking for the next cool thing to apply our technology.
I mean, I guess we kind of have inputs for inputs for everything that like nerve cells are connected to, and we have outputs for every sense that we have. And there's very much like there's definitely a lot of avenues of attacking those, a lot of different angles we can attack those same things from. So like there's a lot of the haptics work right now is when you're holding something. But there's, for example, there's some haptics work by that uses ultrasound, where you basically have you basically shape ultrasound, and you can kind of focus it down on the person's hands, and then you can basically make them feel textures at a distance. So like there's like haptics is very mature in some ways, but even in just like the most mature field, there's still new physics coming out, new types of hardware coming out, and totally new ways of doing things. And so I think there's the same thing in all the fields, and it's almost through more physics stuff than it is through these physics or software usually.
Yeah, I don't think it's as much the way you said that some technologies are kind of getting ignored. It's more that the experience for those technologies hasn't been found yet by the developers of the designers. So once the killer experience is found for that, then it would get used. It's just until that's, like for example, like galvanic skin response. That's a piece of information that seems like it would be valuable, but I've yet to see the great experience that we have to put that into our controller for or something. So if that were to be found, I think then there'd be a no-brainer to put it in. It's just things like that, I think, are what the challenges are for new tech.
Great. I think we're kind of near the end. Maybe we have time for one more question. Yeah.
Hi, hello, nice to meet you. I'm interested in designing games using EEG. So I have a Muse headset. I don't have Emotiv, but I'd like to try it too. And the question I'm at now, I have the content. I know how to generate it. I know how to make it interactive, all this. But then there's the EEG part. I'm not a neuroscientist. I don't know the science. My question, I think this is for you, Tan. Should I invest time in learning how to process those signals and how to go from the signals to the conceptual input to my game? Or is there a technology out there, a platform like you were mentioning before, where all this will be aggregated and treated with machine learning big data to go from the raw signal to the conceptual input that the game takes in?
So the short answer is you can do both. There are already, I called state data, so we've already done the processing. We can give you back state information as to what that output should be, and you can provide that back to the user. Or you can also use the raw data to compute your own, and then have your own proprietary set of algorithms or computations that you might want to feedback. It really depends on the level of interactivity that you want to provide and the level of feedback. A lot of the stuff, if you're just looking at engagement levels, attention levels, stress or levels, interest levels, all of that stuff comes standard with our product. Any sort of facial expressions like smiling, clenching your teeth, furrowing your eyebrows, blinking, all that kind of stuff comes standard. And then the basic mental commands like 4 different commands, say left, right, up, down, those things you can get out of the box without having to do any of your own computation. If you want to go beyond that level, then you would need to do some of your own computation, and that's also available in the SDK. So it really depends on what it is that you want to do.
I guess fast forward 1 year, is this going to get very refined so that no developer should ever think about it? Or will we still see people going down to the raw data?
I think in some of the therapeutic applications, there are certainly areas where people will want to explore their own research. So for example, or even if it's new novel research, like we just did a study with National Geographic on the effects of nature on the brain, for example. That's something that's new. There's not a lot of literature out there. We're building a new algorithm, new neural correlates based on what we're finding there. Similarly, we did a study with the Chopra Center on the effects of meditation on the brain. In those cases, we're building some new data outputs, and we will share that back to the community when those algorithms are refined enough and there's clear outputs. But if it's on a very small sample set, then it's good for a published paper. It's not really good. It's not robust enough to extend to a population set of, 1 million people or several 100,000 people. So it really depends on the nature of the classifier, the nature of the algorithm, and what stage it's at. And we generally phase things in. If you reach out to us as a company, we will sometimes say, okay, we've got some of this cool stuff that's under the hood. It's not publicly available, but if you want to work on that and extend it, you're welcome to access it. So it really depends on the nature of the relationship with who we've worked with and whether they're willing to share that with others or not.
Thank you.
Great. Well, I want to thank all of you very much for a very informative panel again, and we appreciate it.